Okay, so I have started by creating a folder called My C Project, and inside of this folder I'm going to make my root CMake lists. So when you run the command CMake, it looks for this CMake lists. That's just syntax you have to use. So I'm going to start by print message to people. I'm going to give us a status message. You can have error, warning, etc. I'm going to say inside root CMake list.txt. You don't have to have these spaces like this and this, but I like to put them in there. Next, I'm going to print one at the end that says finished root CMake list.txt. Okay. Now I'm going to open up my terminal. I'm going to clear it. CD backwards. Oops. My C project. I'm gonna remove directory, remove folder, build, because I want to make a new build inside of here. Build and change directory, build. Yay! So if I go back one directory and do a line search, you'll see I have a build folder and my CMake lists. So let's go back into build and let's type CMake ... So this warning tells me something, but I want to go to our output first. So this is our CMake, and then this is CMake setting itself up. Great. Now this warning says we need a project name. CMake is pretending there is a project on the first line. So let's copy this and let's paste this into our file. So project name, My C Project. Okay. Now I want to print a message that says project name assigned to. Now I could type My C Project in here, but it's actually good to take advantage of the set function, where I can set a variable called project name. Typically you do these in all caps, like project name, My C Project. And then here you can access this variable with $ open bracket, and then you put the variable name in. I don't know why this is the syntax for it, but it is. So this is a comment set the project name. Now I can type a message that says, oh, I did that already, I just botched my enter. Assigned to project name. Great. Now let's run our CMake again. Okay. When you see these dots, in the same way that you can do this, when I type CMake ... it's going to go one folder backwards and look for a CMake lists.txt. So it goes backwards, it finds it, and it executes. So now you can see my printouts inside root CMake lists, project name assigned to My C Project, finish root CMake lists. Great. So like I've said before, there are three things you need for a CMake to build an executable. You need a minimum version of CMake, you need a project name, and you need a target. So CMake minimum required, and then we can say version, because it's looking for a minimum required version. So this is the syntax to do that. And then we can set it to our variable CMake version. Or sorry, like CMake min required. We'll call it that. Then we can go to the set and we can make this value 3.16. Yay! So then we can make a comment, set the minimum required CMake version. And then we can give a message that says message status setting to, and then we can give our variable CMake min required. Yay! So now we can do CMake and we have a good output. So if I line search into this folder, we have a cache, which is how it stores its variables for repeated use, and then CMake files, CMake install.cmake, and then this make file. Make file is what we're going to use when we run make. That's what we're ultimately building with CMake, is our make file. And then when we run the command make, that's what actually links all the libraries and compiles the code into an executable. So we'll go into more of what that means in a little bit, but this is the basic idea of a CMake file. The last thing we need is to add an executable. We'll call it my executable, and then typically we start with our main.c. So let's do a CMake, and then it gives us an error. It says we cannot find our main.c. So we need to create that. So we'll put it in the root directory for now, main.c. And then in C and C++, the program starts with int main parenthesis parenthesis bracket bracket. This is what the compiler is looking for when it starts the program. So main is the entry point, and whatever comes after main is where the program will start. So that's how you build C and C++ programs. So now if I go back and run this, you see it works great. And now if I line search again, you can see we have this beautiful executable sitting here. And then if I run it, you can see there's no output, but it works well, meaning there's no errors. So to get some output, we can use the standard IO library. This is equivalent to import package. This is a generic package in Python, and it's part of the C standard. That's what std includes. So this is part of the C standard includes. To print, you do print f, and then you give it the open quotes, and you say inside, what are we inside? Main. Then every statement in C++ requires you to end it with that semicolon. It's a syntax thing that lets the compiler know you have finished your line of code. Now we can finish main. Blump. Now if we go back here and I always like to regenerate the make file, even though I don't think you have to. We run our make command. Yay! Now we can use the \n to make new lines. Yay! Yay! All right, so we've now set up a basic CMake list and a main for our C program. So the next thing we want to do is we want to learn a little bit about variables and how to allocate memory inside C for functions and arrays and whatnot, and structs. All right, that's where I'll stop this video.